All right. Center of mass in 2D, I call it Tetris because there's a part in here that looks kind of like Tetris, okay? To solve for the center of mass in 2 dimensions, you have to solve for the x component and or the x coordinate and the y coordinate separately. So solve x and y coordinate separately. Okay, and to do that, you're just going to use the same equation that we've learned, but you're going to apply it to the x and the y axes. Okay, so mass I times xi over the sum of all masses. Okay, and then the y is going to be sum of mass I yi instead of x, okay, because we're going in the y direction now, okay. And then when you get that, that gets you your x coordinate, gets you your y coordinate, and then you can figure out where on the coordinate plane your center of mass actually is, okay. Okay. These examples right here, you can see there's 3 different examples. So when it says, by the way, second and third figures show objects with constant density, that's referring to the fact that the length is directly proportional to the mass of the object. So while it may not be, or while it may be, um, for example, like the length of like the wire here is going to be the same as the mass of it, okay, and then the area of these 3D shapes or these 2D shapes are going to be the same as the mass of those shapes, okay, and I'll show you how to solve those when we get there. So first off, we've got a system of 3 particles, and we need to figure out the center of mass of those, okay. So what we can do, okay, is let's see. I've got my 5 kilogram down here, 2 kilogram up here, 3 kilogram right there. I need to solve for the x coordinate of the center of mass and then the y coordinate, okay? So I'll do the x coordinate of the center of mass, which will be equal to, I take my five, and I take the x coordinate of the 5. So 1, 2, 3, 4, so -4, okay? Add to that my 2. Okay, x coordinate of that is 1, 2, 3. It's -3 because it's left of the axis. And again, you could define the axis however you want. I'm just using the most common way to do it. Don't confuse yourself with this. Okay, and then I take my 3 kilogram and I multiply it by its position 2, and then I take the total mass, which is 5 plus 2 plus 3. Okay, and you should end up getting -20/10, which is just -2. Okay. So it's at a position -2. Okay. Okay. The y center of mass, okay, is going to be solved very much the same way. Oh, why am I doing x? 5, okay, times, and now this time I use the y position, so -1, -2, -3, -4, okay, plus, and sorry, there's a plus, there should be a plus sign right there, plus the 2 kilogram mass times its y position, 1, 2, 3, okay, plus it's the 3 mass at its position -1, -2. Do you see that these are basically the same? These are the same, exact same setup. You see that these are actually going to be equivalent to each other. You see that, right? Okay. And so that also gives you -20/10, which is also -2. So we've officially assembled or we've been able to derive where our center of mass is. Okay. So if I do, what is it? I'm just going to do Cm would be at -2, comma -2. Okay. So -2, -2. Boom. There's my center of mass of the whole system. Okay, it doesn't matter how you would have defined the system. If you maybe said the origin was like over here on the left, that's fine. You'd get the same center of mass. Okay, entirely up to you. If you made the origin down here, get the same center of mass. Doesn't matter where you consider it from. Entirely up to you. Okay. Okay. The wire here, these wires. Okay, here's what I'm going to do. The length of this wire going across is 8. Okay, so what I'm going to do instead of like, oh, the center of mass of like a wire is kind of hard to find. So what I can actually do is I can find the center of mass of each individual segment and then calculate the center of mass from the center of masses of the segments. That's perfectly valid. So you see this segment right here, this whole long segment that's horizontal, okay? The long horizontal segment, that is a segment of length 8, so the midpoint is 4. So 1, 2, 3, 4. So this is where my center of mass of this rod is. And I'm just going to make the center of mass equal to the total mass of the rod. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's the mass of 8. The vertical part right here is also 8. And the midpoint, okay, let's see, 1, 2, 3, 4. Okay, also 8. Can you see that? My pen's kind of getting weak on me. Okay. And then this little segment down here of 2, the midpoint is obviously right in the dead center, and this is just of length 2. So now instead of solving it with all the wires and making things really hard on myself, let's just solve it with the points that I marked. You can do that. That's perfectly fine. Okay. So to find the x center of mass, okay, we're going to do 8 times negative 1. Okay, you're going to do plus 8 times negative 3 plus 2 times negative 2. Okay. And you're going to divide the whole thing by 8 plus 8 plus 2, because that's the total mass of the system. Okay. And you should see that it ends up being negative 36 over 18, which is negative 2. Okay. And then when we do the y center of mass, okay, I'm going to do the 8. One of them is at a position 2. That's this one right here. Okay. One of them is at a y position of 1. Okay. And the 2 is at a position negative 3, looks like. Okay. Over 8 plus 8 plus 2, you end up getting 18 over 18 when you calculate that out, which gives you 1. So the center of mass would be located at negative 2 comma 1. Okay. So negative 2 is 1, 2, and 1 is up here. Okay. There's my center of mass. Okay. Okay. Now the last part is the most complicated. Okay. But you have a this object right here. Okay. That would be these are like segments of like blocks, right? Okay. Okay. This one up on the top has an area of 24, and the center of mass is dead center on it. So it has a height of 3 and a width of 1, 2, 3, 4, 5, 6, 7, 8. So the midpoint here would be 4, and then the midpoint here would be 1.5. So it'd be right about there. So this is a mass of 24. Okay. Then I'm going to take the legs. So I'm actually going to break the legs off here. Okay. And I'm going to do this. These each have an area of 12, okay? And they've got, let's see, so it's going to be in the middle here, and then 1, 2, 3, 4, 5, 6. So then 1, 2, 3 right there, okay? And it's same on the other side. This is 12, this is 12, okay? And all I got to do now is to find the x position of the center of mass is do 24 times its x position negative 1. And again, I'm just doing it from the dots, okay? Plus 12 times negative 3 plus 12 times 1. Okay, and we put it all over 24 plus 12 plus 12, and we set that equal to negative 1. Okay. The y center of mass, or sorry, that's not the set equal to negative 1. That whole thing is going to end up being negative 1 if you calculate it out. The y center of mass is 24 times 3.5, okay, plus 12 times negative 1 plus 12 times negative 1. Okay? 24 plus 12 plus 12. That ends up giving you about 1.25, okay, which is kind of an odd number. So the center of mass is going to be located at negative 1 comma 1.25. Okay, so I'm going to go there. Negative 1 comma 1.25. There's 1, and then about 2.25 is right about there. Okay. See how that works out? Okay, that's center of mass in 2 dimensions. It's kind of crazy. It's kind of weird to think about, but it is there. Okay.